Hello guys, welcome to today's learning video from eLearners, an e-learning platform that provides tailor-made revision videos. Today we'll be learning about simulation from operations research management. So what is simulation? Simulation is a general method used to solve problems in inventory management and queuing problems. When do we use simulation? Simulation is used when the costs and the dangers of experimenting in the real world. Also, simulation is used when there is difficulty in observation. For example, in space research. The other way simulation is used is when the period of observation is long. For example, when you are dealing with problems related to population. One of the techniques that is used in simulation is the Monte Carlo simulation technique. This technique uses random numbers to simulate a problem and to try and find the appropriate solution to the problem. So when carrying out Monte Carlo simulation, there are several steps that are followed in order to come up with the solution. The first step in the Monte Carlo simulation technique is setting up the probability distributions for the various random variables. The second step is using the cumulative probability from step 1 of the random variables. The third step is setting up the ranges, the random number ranges, using the cumulative probability that you have created from step 2. The fourth step is running the simulation trials. We'll do question 5 of our handouts, whose link has been provided below. The question states that Mwangaza Limited provides electricity to a town in northern Kenya through a series of over 150 generators. The generators occasionally break down as expected, and hence management has a 24-hour repair. Engineer on standby for such an eventuality. They are paid cash shilling 24.90 per hour when they are on duty. Mwangaza Limited aims at providing uninterrupted power for its clients, and so when one of its generators is down, it purchases power from a competitor at a rate of 6,300 per hour. Data for the last 100 recorded breakdowns on time between breakdowns and repair time required in hours as follows. So we have time between breakdowns, number of times, and also we have repair time. So the time between breakdowns so we have 0.5, 1, 1.5, 2, 2.5, and 3. And the number of times, so this is provided for the time between breakdowns. So the number of times this has occurred, we have 5, 6, 16, 33, 21, and 19. And also we have been given repair time. So the repair time is in, we have 1, 2, and 3. And the number of times that this has occurred there is 28, 52, and 20. So the question requires us to perform a simulation for 15 generator breakdowns so as to determine the relevant average cost per generator, taking into account the following. So the first is use a 24-hour clock and assume the simulation begins at 00 hours, and then we have been given random numbers, and we have been told to use an allocation system of 01 to 00. So we need to first find the random number ranges. So the first thing we do is first finding the probability of the time between breakdowns. So the first thing we do, we add up the total of the number of times that the breakdowns occur. So we first add the total of the number of times. So 5 plus 6 we get 11, plus 16 we get 27, plus 33 we get 60, plus 21 we get 81, plus 19 we get 100. So In order for us to get the probability, the first thing we'll do is divide each by the total. So the probability will be 5 divided by 100 will be 0.05. Here we have 0.06, 0.16, 0.33, 0.21, and 0.19. Remember when we talked about our steps in the Monte Carlo simulation technique, we said that after probability, we are supposed to get the cumulative probability. So the next step that we take is the cumulative probability. So the cumulative probability will be 0.05, and then 0.11, 0.27, 0.560, 0.81, and then 1.00. After taking the cumulative probability, the next step will be the random number ranges. For the ranges, in the question, they have told us to start from 0, 1 to 0, 0. So that's the criteria that we use when allocating the random number ranges. So the first one will be 0, 1 to 0, 5. The next will be 0, 6 to 11. The next will be 12 to 27. Then we have 28 to 60. Then 61 to 81. Then we'll have 82 to 00. So this is the repair time hours and the number of times that the repair time hours occurred. So our next step is finding the probability of the repair time hours. So the first step is adding up the number of times. So 28 plus 52 will be 80, plus 20, that will be 100. So after getting the total, we'll get the probability of this occurring. So how do we get the probability? The probability will take the number of times divided by the total. So 28 divided by 100 will be 0.28. Then this will be 0.52. And the last one will be 0.20. After getting the probability, we'll get the cumulative probability. So for the cumulative probability, we'll use the probability. So the first one will be 0.28, the second one will be 0.80, and the third one will be 1.00. After getting the cumulative probability, the next step will be to get the random number ranges. So for the random number ranges, we use the cumulative probability. And as per the question, we'll still use 0, 1 to 0, 0 as our basis to find the random number ranges. So the first one will be 0, 1 to 28. The second one will be 29 to 80. And the third one will be 81 to 0, 0. So after finding the random number ranges, this is the first step in order for us to be able to run simulation trials. So the next step is running the simulation trials. So I hope everyone has written, so we wrap this to create space for running the simulation trials. So as per the question, we'll be running the simulation for 15 breakdowns. So we need to simulate 15 times to find the hours that the machines broke down. So the first column will represent the random number for breakdowns. So these are the bottom of the question. So we have 57 Then we have 17, 36, 72, 85, 31, 44, 30, 26, 09, 49, 13, 33, 89, and 13. So these are the random numbers given as per the question. So the next step is finding the time between breakdowns. So the way we do this, remember the first table that we created when finding the random number ranges. So we'll be using the random number ranges by checking the random number that we have been given and the range that it lies in. So in this step, so we use this to find the time between breakdowns. So the first random number is 57. So we'll check here where 57 lies, and in this case 57 lies in between 28 and 60. And as per what we prepared in the table, the time for breakdown that is 57, the time is 2. So for the first one is 2 hours. So the second random number is 17. So it lies between 12 and 27. So the random number, the hour for breakdown is 1.5 hours. Then we have the third one is 36. It lies between 28 and 60. The hours are 2. Then we have 2.5 hours for 72. Then we have 3, 2, 2, and then 30 lies between 28 and 60. So that will be also 2. And then 26 lies between 12 and 27, so that will be 1.5. 09 lies in the second one, so that will be 1. Then the following is 2, 1.5, 2, 3, and 1.5. So these are the times for breakdown that you have gotten from our random number ranges. So remember the question said that we should start at 00 hours to find when the machine broke down. So this column will represent the time that the machines broke down. So the way we do that, so this will represent the time of breakdown. So if we are to start at 00 hours, so after 2 hours, that will be at 2:00, and then 1.5 hours later, that will be 3:30, and then 2 hours, that will be 5:30, and then 2.5 hours after 5:30, that will be 8 o'clock, and then 3 hours later, that will be 11, and then 13:00, then 15:00, then we have 17 hours, then we have 18:30 hours, then 19:30 hours, then 21:30 hours, then 1.5 hours after 30 is 23, then we have 1:00 hours, and then 4, and then 5:30. So this represents the time that the machines broke down. So after getting the time that the machine broke down, we also need to find, so we'll go to the next part where we'll use the repair time. So we need to find out when did the repair happen. So remember we had 3 hours, we had 1, 2, and 3 hours between the periods where repair. So there is a repair that would happen after 1 hour, another one after 2 hours, and then the other one after 3 hours. So our next step will to find first the to simulate the repair time. So for this, we'll use the second table that we prepared. So we'll have the random numbers for repair time. So random numbers for repair time, they are given as per the question. So we have 07, 60, we also have 77, 49, 76, 95, 51, 16, 14, 85, 59, 85, 40, 42, and 52. So those are the random numbers that you've been given for the repair time. So in order for us to get the repair time, we need to use the random numbers and the second table that we prepared to find the repair time. So according to the table that we prepared, so this will be the repair time column. So the random number 7 lies between 1 and 28. So the repair time will be 1. 60 lies in the second between 28 and 80. So that will be 2. 77 will be also 2. 49 will be 2. 76 will be 2. 95 will be 3. 51 will be 2. 16 will be 1. 14 will be 1 also. 85 will be 3. 59 will be 2. 85 will be 3, 40 will be 2, 42 will be 2, and 52 will also be 2. So these are the approximated repair times for the machines when they break down. So after finding the repair time, so first we had the time when the machines broke down, and then this is the repair time. So we need also to have two more columns of when the engineer was free to carry out the repair, and also when the repair ended after he started. So we'll have two columns: when he's free to begin the repair and the time that the repair ended. So we'll have when the engineer is free to carry out the repair, and the time the repair ended. Okay, so when the engineer was free, so for the first machine that broke down, it broke down at 2. So that's 2:00 hours. So the engineer was free at 2 because that's the first machine that broke down. So here we'll have 02:00 hours. Then for the first machine, the time the repair ended will be the repair time, which is 1 hour, added to when the repair started. So the repair started at 2, after 1 hour, the repair ended at 3. The second machine broke down at 3:30. So after breaking down at 3:30, when the engineer was free. So the engineer was free after repairing, the repair ended for the first machine. So the engineer was free at 03:00 hours. But okay, so the repair started at 3:30 and it took 2 hours. So the time it ended was at 5:30. So for this column, okay, so for this is when the engineer is free to start the repair. So for this case, it will be 3:30 because between the period between 3 and 3:30, he was free. There was no machine that broke down. So we'll have the time is free to start the repair is at 3:30. So the repair will end at 5:30 because it took 2 hours. So for the third machine, when is the engineer free to start the repair? It will be at 5:30 because it's immediately when he ends repairing machine 2. So for machine 3, it takes 2 hours, so it will be 7:30. For the fourth machine, it broke down at 8, so the engineer is free to start the repair at 8. It will take 2 hours, so it will be at 10. the fifth machine will. So the fifth machine breaks down at 11. So the time when the engineer was free to start the repair was at 11. And so the fifth machine takes 2 hours to repair. So the repair will end at 13:00 hours. Then the sixth machine, the engineer is free to breaks down at 13:00 hours, and the engineer will be free to repair at that time because he ended the repair at 13:00 for the previous machine. So the engineer is free at 13:00 hours, and it takes him 3 hours to repair that machine. So after one, so we'll have 16:00 hours, and then the seventh machine will break down at 15:00. So at 15:00, but the engineer for the when they were repairing the sixth machine, the repair ended at 16:00. So the time when he will be free will be at 16:00 to start the repair. So it will take him 2 hours to repair the seventh machine. So 2 hours from 16 will be 18:00. The eighth machine broke down at 17:00 hours. So the engineer ended the repair for the previous machine at 18:00 hours. So the time when he's free to begin the next repair is at 18:00. So it will take him 1 hour to repair the machine. So 1 hour from 18:00 will be 19. Then the next broke down at 18:30, but the repair ended at 19:00. So the time to repair will be 19:00, and it will take him 1 hour. So it will be at 20:00 hours. And then the next machine broke down at 19:30. So but the engineer is free at 20:00, and then it will take him 3 hours to repair that machine. So it will take him up until 23:00 hours. So after that machine, the next one broke down at 21:30, but the engineer completed the repairing of the previous at 23:00. So the time is free is at 23:00 to repair the next machine that breaks down. So it takes him 2 hours. So it takes him 2 hours to repair that machine. So he'll end at 01:00 hours for the repair of that machine. And then the next broke down at 23:00, but the engineer is only available at 1. So it start at the time is free will start at 1, and then he'll complete it after 3 hours, which will be at 4. And then the next machine broke down at 1, but he was free up from 4. So he'll take the repair from 4, and then that will take him 2 hours. So that's up until 6. The machine that broke down next broke down at 4, but the engineer was free at 6, and then it took him 2 hours, so he completed it at 8. And then the last machine that broke down at 5:30, but the engineer was free from 8. So he'll start at 8:00, and he'll complete it after 2 hours, which will be 10:00 hours. So that's the simulation for the time that it takes to repair the 15 machines, and we have seen that the last time will be at 10:00 hours. So the next thing we need to do, we need to find the time that the machines broke down. So the time that the machines broke down will be a difference between when the machine broke down and until the time it was repaired. So in this case, we have this column of time for breakdown. So we'll have this column of time, total time of the breakdown. So for the first machine, it broke down at 2 and the repair ended at 3. So it took 1 hour for it to be repaired. The second one broke at 3:30 and by 5:30 it was repaired, so we'll have 2 hours. So we'll be using this column and this column, this furthest column. The third machine broke down at 5:30 and the repair ended at 7:30, so those are 2 hours. And then we have the fourth machine broke down at 8 and the repair ended at 10, so we have 2 hours. And then we have the next machine breaking down at 11 and the repair ending at 13:00, so we have also 2 hours. Then the other machine broke down at 13:00 and the repair ended at 16, so it took 3 hours. And then the other machine broke down at 15:00 hours and the repair ended at 18:00 hours, so it took a total of 3 hours to repair that machine. And then the next broke down at 17:00 hours and the repair ended at 19:00 hours, so we'll have 1 hour. We have 2 hours, 2 hours. And then the next broke down at 18:30 and it was repaired at 20:00 hours, so that took 1 hour and a half. And then the next broke down at 19:30 and the repair ended at 23:00. So those will be 23, 19, that will be 3.5 hours of repair. And then the next machine broke down at 21:30 and it was repaired at 1. So for that we'll have 3 hours, we'll have 4 hours and a half for the repair, 4.5 hours. And then the next machine broke down at 23:00 and it was repaired at 4. So it took 5 hours for the machine to be repaired. And then the next machine broke down at 1 and it was repaired at 6. So it took 5 hours to be repaired. And then the 14th machine broke down at 4 a.m. in the morning and it was repaired at 8. So it took 4 hours. And then the last machine broke down at 10:00 hours and it broke down at 5:30 hours and it was repaired at 10:00 hours. So it took a total of 4.5 hours for it to be repaired. And then we'll need to add the time so that we can get the total time for the breakdown. So we are finding the time that the total time that it took for between the breakdown and the repair, when the repair of the generator happened. So while doing the breakdown, the total time, so when deducting 1:00 hours and 21:30, so here we are supposed to get 3.5 hours. So that's a correction on the previous workings. So we need to find the total time that it took for the breakdowns of all the 15 generators. So we'll add these totals, of which we get 44. So the question had asked us to perform a simulation of 15 generator breakdowns so as to determine the relevant average cost per generator. So in the question they had given us the cost. So they say the engineer is paid 2,490 per hour when they are on duty, and also when there is a breakdown they purchase power from a competitor at a rate of 6,300 per hour. So because we have gotten the total hours that it took for the entire generators, we got 44 hours. So that is for the 15 generators. So we need to find now the cost. So we'll be taking 44 hours and then 44. So we have 44 hours as the total time for breakdown. So we got 44 hours. So the question had told us that the company pays the engineer 2490 shillings, 2490 for each hour that he's on duty, and also they purchase power from a competitor at 6,300 when the generators break down. So in order for us to find the average cost of the generators when they have broken down, so we need first to find the cost, the total cost. So we'll take 2490 and multiply it by 44, and then also take 6300 multiplied by 44, because remember this is the total hours that the generators had broken down. So when we take 2490 multiplied by 44, we get 109,560. And then also when we take 6300 and multiply it by 44, we get 27,200. So we are supposed to add both these so that you can find the total cost that the company pays when the generators are broken down for 44 hours. So when we take 109 plus 27,200, we get 386,760. So this is the total cost, both for the charge of the engineer and the purchasing power from a competitor. So in order for us to find the average cost per generator, we'll take 386,760 divided by the number of generators that we simulated, which is 15. So the average cost per generator will be 25,784. So 25,784, that's the total, the average cost that the company incurs when one of the generators has broken down.